Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today's topic is memory organization of 8051 microcontroller. This video is a part of series microprocessors and microcontrollers. Coming to the overview of today's presentation, what are the computers based on their memory, like von Neumann architecture and hardware architecture. And in 8051 on-chip memory, off-chip memory. Look, so coming to the computer architectures. So memory is an important element in any system. So whether it is microprocessor or microcontroller. In the microprocessor, we need to interface memory from the outside world. But in the case of microcontrollers, the memory is inbuilt. So depending upon the memories, there are two types of architectures will be there. In microcontrollers, depending upon the memories, there are two types of architectures. That one is a von Neumann architecture and the second one is Harvard architecture. So what is von Neumann architecture and Harvard architecture? So we will know why we are discussing this von Neumann architecture and hardware architecture. So better view of 8051 memory organization, we must know which architecture of memory we've been using in 8051 microcontroller. So coming to the von Neumann architecture. So in von Neumann architecture, it is also known as Princeton architecture. So in this particular architecture, the memory which we are using is of only one memory block. The data will be here, the program will be here. So if we want to access the program memory, this memory will have data as well as program. If we want to access the program memory, so that particular data will be movable from this memory. So we can't access data at that particular case of time. So this is the drawback in von Neumann architecture. The two memories, the data memory and the program memory, both the memories will be saved in a single memory chip. So we can't able to fetch the data while the program memory has been executing. So this is the problem with von Neumann architecture. So due to single bus limitations, so see, this data memory and this data memory and the instructions, both of them share the same memory. So CPU cannot access memory simultaneously due to single bus limitations. If we are using the single bus to fetch these two memories, so it is impossible to fetch the second memory while the first memory has been executing. This is the problem with von Neumann architecture. So in 8086 microprocessor, as I already discussed that the same problem arises in 8086 microprocessor also. The same memory has been used for data and instructions also. So at that particular time, the 8086 memory has been segmented into 4 different sections, right? So by using different to fetch data, there is a data bus. To fetch the program, there is a address lines. So such type of a segmentation has been implemented in 8086 to avoid this problem. So the other architecture based on the memory is Harvard architecture. In this Harvard architecture, so that problem which we have faced in the von Neumann architecture has been rectified by using two separate memories for data and program. See, the data will be stored in this data memory and the instructions which we are writing as a program will be saved in program memory. So if the processor want to fetch the data, it can fetch the data by using the data memory, and if the processor able to execute the instructions, it can directly go to the program memory and it can access the instructions from the program memory. So by using this Harvard architecture, we can override that problem of having the same memory. So this Harvard architecture has been implemented in our 8051 microcontrollers. So our microcontroller which we are using here is a 8051 microcontroller, and in this microcontroller, the architecture which we are using is of Harvard architecture. That's why we are having two memories, data memory and program memory in 8051 microcontroller. So the data memory here is a 128 bytes, which is RAM, and the program memory, read-only memory, which is ROM, is of 4 kilobytes. So internally, the microprocessor 8051 can support 128 bytes of RAM locations and 4 KB of memory of ROM to store the program. And it can also support 64 kilobytes of RAM and ROM of external. If the application needs more than 4 KB of a ROM, then you can interface other external memory devices. Such type of memory devices up to 64 KB can be supported by 8051 microcontroller. So here the internal RAM organization of 8051 has inbuilt IRAM means internal RAM, IROM means internal ROM. So off-chip, you can also call it as a on-chip RAM, on-chip ROM. So for the external memory, you can call off-chip ROM, off-chip RAM. So here IRAM is of 128 bytes and IROM is of 4 kilobytes. So coming to the memory organization, how this IRAM has been divided. So this IRAM is divided into 3 parts. The first part is of having 32 bytes from 00H to 1FH. So these 32 bytes of locations has been reserved for the registers R0 to R7. In the previous video, I have already told that there are 4 memory banks in 8051 microcontroller, bank 0 to bank 3. So these 4 banks will consist of R0 to R7 registers. So total 32 register R0 to R7 registers will be there from the bank 0 to bank 3. So these 32 registers data will be stored in 32 bytes of internal RAM. First 32 bytes of internal RAM will be used to store the register values of bank 0 to bank 3. And these can be accessed by using direct and indirect addressing mode. So you can directly directly mention register R0, R2, R3 in the instruction itself, or you can use the address location of that particular register. If I mention @IE, so it represents that the data present in that particular address location in the instruction. The first 32 bytes of internal RAM of 128 bytes of 8051 microcontroller is reserved for the register sets R0 to R7 of bank 0 to bank 3. So the next 16 bytes, so address locations is from 20H to 2FH, are either byte addressable or bit addressable. You can address it by using the addresses or you can use it by the direct bits. The remaining 80 bytes of 128 bytes, you usually use it for the general purpose storage and they are byte addressable. So you can mention directly the address of that particular memory location. So coming to this is the internal RAM organization. So these are the 32 bytes which is reserved for the registers. See, bank 0 is having R0 to R7. You can either use indirect. So addresses from 0 to 07 will be used for the bank 0 and the addresses from 08 to 0F. As the address locations of 8051 is also of hexadecimal number system, so it will be represented by using F. So bank 1 is from 08 to 0F locations and bank 2 is from 10 to 17 and bank 3 is from 18 to 1F. So if you want to utilize these registers, you can directly mention the register in the instruction itself or you can indirectly mention the address of that particular register. Suppose if I want to write move R3, 12H. So in microcontrollers, we will be using hash symbol to represent raw data, direct data. So here, if I was using R3, it represents the R3 of bank 0. Why it will represent the R3 of bank 0? Why can't be it bank 1 R3, register R3 of bank 1? So there is one thing that if you directly mention the instruction like move R3 comma hash 12H, the data of 12H will be directly stored in R3. So that's fine. R3 is the register R3. So why bank 0 will be selected? So as I already told you in the previous video while explaining the PSW or flag register, program status word of 8051, that there will be two registers like R3 and P3 and P4. So these two pins will select the banks. So at a time you can utilize R0 to R7 registers of any one particular bank. If I want to use bank 1, then you need to set the P3 and P4 values of PSW to bank 1. To select bank 0, 0 will be there in that P3 and P4. So if you want to select bank 1, 0, 1, bank 2, 1, 0. If you want to select bank 3, 1, 1 will be chosen. So how to write the program to select? Suppose I want to select bank 2. So you need to write set PSW dot, if it is 4, so PSW dot 4. So the fourth pin of PSW will be set to 1. So basically, while we are loading the PSW, while we are writing the program, this usually 0, 0 will be there in the two pins. So bank 0 will be selected. So if you want to choose bank 2, you need to choose 1, 0. If you want to choose bank 3, you need to keep 1, 1. So this is how. So okay. Now this instruction like move R3 comma hash 13H can also be written in another form like move at the rate, what is the value? 03 comma hash 13H. Like we are placing 13H value in 03 location of RAM. 03 location of RAM, which register it will hold? R3 register. Okay. This is how we will use the indirect and direct addressing modes of these particular memories of 32 bytes. So coming to the next one, it is bit addressable and byte addressable. These are used the same way. So these 16 bytes will be addressed by these addresses or by using the direct data itself. So these are the general purpose remaining out of 128. This 32 and this is 16, 48. So the remaining will be 80. So these 80 will be used. These 80 locations will be used for general purpose. This can be used for stack registers. This can be used for any general purpose registers. So this is how internal RAM organization of 8051 128 byte has been divided. Okay. So coming to the internal ROM. Basically, the internal ROM is of 4 kilobytes IROM. So this memory can be stored like this IROM 4 kilobytes. So to address 4 kilobytes of a memory, how many bits, how many address lines are needed? To address 4 kilobytes, so 2 power 12 is equals to 4 kilobytes, right? So we require 12 address lines. So the maximum size of 12 address lines is, so this will be F, this will be F, and this will be F. So that's why the 4 KB will be address locations of that 4 KB will be 4 zeros to 0 triple F. So this is how IROM will be there. Total, here I have mentioned that I have already told you that if we want to access external memory of 8051, so how much memory it can support? It supports 64 KB of memory. So to support 64 KB of memory, we've been using 16 address lines in 8051. So from 4 zeros to 4 Fs, because 2 power 16 is equals to 64 KB. So to address 64 kilobytes of memory, we need to have 16 address lines. Okay. So coming to the off-chip memory. In off-chip memory, so which 8051 supports, it is of 64 kilobytes, right? So there are two versions in of off-chip memory, RAM and ROM. So as I already told you, RAM is a random access memory, so it can store the data. To access external RAM, there is a 16-bit register, DPTR, data point register. So to access the external memory, RAM memory, we've been using this DPTR register. So coming to the ROM, here off-chip ROM of 8051 can support 64 KB. But the thing is, here out of 64 KB, if the processor want to fetch the data, first it will fetch the internal data of 4 kilobyte and external data of 60 kilobyte, total 64 kilobyte. So how it will fetch internal while using the external means, if EA pin, external access pin in pin diagram of 8051, so EA pin is grounded, means if EA equals to 0, then only this external ROM will be accessible. So external access pin is equals to 0, then only external ROM will be accessible. And the external ROM will always be encountered by the program counter, PC, program counter register, which is of a 16-bit register. So if EA pin is equals to VCC, so if EA equals to 1, like if we are using 5 volts, VCC, then 8051 first access the on-chip RAM, on-chip ROM, that is 4 zeros to 0 triple F. Then before switching to off-chip ROM, so basically the off-chip ROM locations will always start from 1000H to 4F. How? Let us see. So this is the total off-chip ROM, 64 kilobytes. So it will always start from 4 zeros to 4Fs. But while we are using, this is EA equals to ground, 0. Total external will be there. If EA equals to VCC, then there is two things. First, it will access the internal ROM, that is of 4 KB, starting from 4 zeros to 0 triple F. Then it will switch to the external ROM of 60 KB from 1000 to 4FH. This is how off-chip memory of 8051 looks like. So until now I have discussed that how classification of microcontroller depends upon the architecture of system will be, like von Neumann architecture, Harvard architecture, and how internal and external memories of 8051 has been organized in 8051 microcontroller. Thank you.